Bavas. My class ID is 3. So this is the Big Data Programming Spark icp4. So in this we have given a task of Spark streaming. So Spark streaming is a core API of Spark. It enables high scalability, throughput, and fault tolerance, and it processes live data streams. So it also has a high level abstraction stream called discretized stream, which is also called as D stream. So it's a continuous stream of data. So here we have given two tasks and a bonus tasks. So the first task is to use a log file generator and generate word count for the log files created. So let's get into the first task. So this is the first task. We have given a source code of this lorem text. So I'll be generating log files from this text. So there are no log files right now. By using this Python program, I will be creating log files. So here I'm importing random int from the package called random, and I'm importing the time also so that I can print the time. So this is the main function. uh, so if the name is equal to main, the main function will be executed. So I'm taking a variable a which is equal to 1, and I am opening this text file as file in read format. uh, so uh, the text file is present in this variable now. So I am reading lines from this file, and I am placing it into the variable lines. So while a is less than 30, so I'll be creating 30 log files now. So the length of the each line is put into the total line, and here I am generating a random integer from 0 to the total length. Suppose the total length of the first line is some 50. It will be generating a random integer called which is between 0 to 40, and I'll be placing it in this variable called line number, and I'll be creating this log file with the format. uh, the first number will be 1. So here I'll be creating log1.txt, log1.txt in the first loop, and the I'll be keeping that into the variable called write file. So I'll be writing into that file, uh, and I'll be joining with uh, uh, like this is a list. So in the list I'm giving a for loop. In the for loop, uh, I'll be generating lines from line number to total line number. That is like I'll be generating random words, and I'll be placing into the log file. So I'll be increasing a value so that I'll be creating more files, and the wait time is 5 minutes. So for the 5 minutes the timer will be slept. And this is the streaming. This is the streaming code. Here I'm importing OS, so I'm not using any of the logger functions here. I directly put logger here, so we can just remove it. Remove it. So here I'm setting the environment as Spark Home, and I'm giving the Spark Home location of the Spark here, and I'm creating a Spark context here, and I am giving the name as network word count, and I am giving the context as local. So here I have given some loggers so that I don't see any log infos in my terminal. So here I have given the streaming context from the Spark context. It will be generated for every 3 seconds. So with the context, I am setting in files input stream which I have created in the log folder. So those lines will be flat mapped with a lambda function by splitting each and every word with space. So each and every word will be present in words variable. So the words variable will be mapped with a lambda function. This is for counting the words, and they will be reduced uh, by this lambda function. And I'll be printing the words here. So in order to print, I need to start the text, the streaming context, and the streaming context will be waiting in the terminal with this function. So let's just execute it. It will take some time. So here the streaming has started. So now I'll be generating the log files. See, as you can see, the log files have been creating here. So I'm getting the word count of those log files from here. So it will be continued till all the log files are generated and all the data is retrieved. So I think this is enough for the first task. I'll be stopping here now, stopping it here. So let's go to the task 2. So the task 2 is write a word count program to receive data from a TCP socket. So we will be using netcat utility here. I have already installed netcat in my system. uh, it's basically just write pip install netcat here. That's it. So here is my code. It's similar to the first one. The only difference is we'll not be taking the data from a local. We'll be taking it from a local host 600. That is, we'll be running this port number in my terminal, and I'll be giving the text. So it's the same thing. I don't need to explain it. I'll just run it and show it to you. So it's telling me the connection is refused as I didn't start the port. The port was 6000. So I started it. I'm giving some details as this. So here it started. So here I have given the data as Bowers data. hero is a. So here is the output for that. So this is the task 2. And the bonus one is counting the character frequency. The output should be in this format. If we give 3 words with same length, it should come in this list, and the length should come here. So I'll be showing you the code for that. See here, everything is same. I just changed the port number. You can just keep the same port number as given in this one. It's the same code as that of the uh, word count. I just made some changes here. In the mapper, I have taken the length of the word and the word here, whereas in here I have taken the word and I'll be taking this one for each word, and I'll be adding if the number of words increase. So here, uh, so if after I take the length, I'll be increasing the number of words. So if I give cool and good, first cool and uh, length of the word cool 4 will be sent here. After that, if I send good, 4 and good will go. So I'll be adding cool and good into the list. So I'll just execute it and show it to you. So I need to start the connection. So here I have given Baba's good, cool, super. So Baba's, the length of Baba's is 6. The length of good and cool is 4. Super is 5. So the output is here. So is, as it has length of 2, so it's been printed here. Hero is length of 4, it's been printed here. That's it. Thank you.